Alright, hi and welcome back to our educators. So this is video part 2 for your Voltaic cell. So I'm going to explain to you macam mana nak buat this question lah. So in the previous video I already give the tips macam mana about Voltaic cell. Okay, so I already give a very long and detailed tips to answer. So now we are going to answer based on this guideline. Okay, so just a minute, I save this guideline and tunjukkan you as well. Okay, okay, so I save the guideline. Okay, so now electrode magnesium and electrode argentum tadi I dah tentukan the value, right? Okay, so my first is determine anode and cathode. How to determine? Okay, E naught more negative is anode, E naught value more positive is cathode. So saya dah settle lah yang ni. Okay, macam mana saya dah settle kan? Okay, come I show you. Okay, which one more negative between these two? Negative 2.32 lah, more negative, right? So you should say, okay, magnesium electrode is anode. Why it is anode? Because E naught value is more negative. Okay, so this should be your first answer. Then your second one is, you should say argentum electrode, which is a silver electrode lah. So silver electrode is cathode because E naught value is more positive. So this should be your first answer. Okay, so after you dah bagi tahu macam ni, then what you should do is you should tell the process lah, yang mana oxidation, yang mana reduction. Okay, so magnesium. Okay, magnesium is Mg2 plus lah, betul tak ion dia? So you can say Mg2 plus is your anode. So anode undergoes oxidation. Okay, because it is anode, that's why they undergoes oxidation lah. Okay, while your silver electrode is your Ag plus lah. Okay, Ag plus undergoes reduction. Okay, so make sure you tahu what happens at anode and cathode. I dah give the mnemonic anode straight cat, so make sure you follow that. So Mg2 plus undergoes oxidation, Ag plus undergoes reduction. Okay, so after that what you should say? Okay, so after what you should is, you should say the half equation. Okay, where to get the half equation? See your standard electrode potential table. Okay, so come, let's refer the table again. Okay, so I already, oh wait, they must load. Okay, this is your table. Okay, you know Mg2 plus undergoes oxidation, so this is your Mg2 plus. Wait, let me to show you with cursor. Okay, but color oxidation, can I take it directly or inverse it? Yes, I can inverse je sebab oxidation kan. So I won't write Mg2 plus first, I will write Mg first. So Mg produces Mg2 plus 2 electrons. This is for my anode. Okay, yang mana dia berlaku oxidation. So just write anode, ANODE, ni half equation dia. Then cathode, CATHODE. Okay, cathode is Ag plus, dia undergoes reduction. Ingat, this table, the whole equation is for reduction. So just copy back the equation. Ag plus produces, Ag plus electron produces Ag. Okay, yang atas ni kan, let's say you tak nak bagi tahu ion, you nak play safe kan. Okay, you boleh kata macam ni. I erase for you. Okay, you can say magnesium electrode undergoes apa? Undergoes oxidation. Okay, oxidation. And silver electrode, you can say silver electrode, which one yang undergoes reduction? Particularly their ion, which is the ion level. Sebab magnesium electrode, you tengok the half equation, anode dia start dengan Mg. That's why I say magnesium electrode. While silver electrode, you see the start from Ag plus. Okay, so you can see argentum ion undergoes reduction. Better lah, lagi better. But when I see back your your example in the textbook, right? Dia tak mention pun yang mana undergoes reduction, yang mana undergoes, just kata Zn is your anode, Cu is your cathode. So when I see back, I macam okay, fine. So lagi better, you tulis kat the side itself. You know anode, because inert value is more negative, you letak comma, oxidation occurs. Macam tu. It's more better. So this is a bit ada perubahan lah, this part. Okay, so let me to correct kejap. Okay. So ni lagi better lah. You write which one is anode, where oxidation occurs. So ni lagi safe. Okay, you tak perlu ingat banyak point. You just combine in one sentence. You bagi tahu electrode to act as what, anode ke cathode, then terus bagi tahu kat sana berlaku apa. So in this case at anode, you know anode, right? So you say magnesium is your anode. So you know at the oxidation will occur. You say silver electrode is your cathode. So you know then reduction occurs. So better answer like this lah. Okay, so after this, I want you guys to answer macam ni lah, my students lah. So no more changes in answering techniques. This is the correct answering technique. So your third and fourth point would be your half equation. Okay, third is half equation. Fourth is your half equation for cathode. Tak kisah lah you nak buat for cathode dulu, anode pun up to you lah. I just tukar A. That's why I write anode first. Okay, after you dah buat yang ni, you should do your overall ionic equation. Okay, overall ionic equation. Okay, your overall ionic equation is a particular part in the video where you have two things to consider. First is you should see the number of electrons. Okay, you should see number of electrons, same or no. You should see that the number of electrons should be same, must be same. And then electron in two opposite places. Okay, what does I am talking about with two opposite places? Okay, is macam ni. Okay, I write down here lah. Okay, oops, page tu lari. Okay, oh, I go to electrode potential table dulu. Okay, this table. Okay, I show you one before arrow, another one after arrow. Okay, so what I'm trying to say with before and after arrow is macam ni. Okay, I cakap sikit tepi. Okay, you tengok your electron is before arrow ke after arrow? After arrow kan? So your second should be before arrow. Faham tak? Dia tak boleh dua-dua after arrow or dua-dua before arrow. Cannot. It's wrong. Okay, so itu is what I'm trying to say in your second rule. So most cases second rule dia akan occupy. Okay, dia akan capai second rule. Kalau you buat betul-betul your table, you tahu guna your table betul-betul for oxidation and reduction, then it's not an issue. Okay, so one is before arrow, another one is after arrow, so it's correct. But the number of electrons same or different? Different. So when the number of electron is different, like how you do for fraction, this one 2, this one 1. So make sure this 1 becomes 2. So you times the whole equation with 2. Remember, when you times 2, this time 2 going to times with all the coefficient in front of the thing. So here also will become 2, here also, everything will become 2. But this 2 won't disturb the charge. The charge will remain the same. The number in front, the element only would change. Faham tak? So it would be 2Ag plus, not 2Ag2 plus. No. The 2 takkan mengganggu your charge ke atas. It won't disturb your charge. It will just disturb the coefficient in front of your element. Understand? Okay, so how I do? Okay, first magnesium, right? Okay, Mg equals to Mg2 plus 2 electron. Okay, and then the down one I times with 2, right? So 2 Ag plus produces, also not produces, 2 Ag plus 2 electron produces 2 Ag. Okay, so this is your half equation, dua-dua yang betul-betul compile the overall ionic equation. But this one you don't change tau, yang ni just remain the same only. Okay, you just follow sahaja whatever you buat kat sini. Okay, you just tinggalkan your half equation like this. You just tablekan when become overall ionic equation part only. I hope you faham. And then now you cut your number of electrons yang same. Whatever same you can cut. So ni 2 and 2 can cut lah. Okay, so the remaining are not same. Mg and Mg2 plus tak sama, Mg and Ag plus pun tak sama, Mg and Ag pun tak sama. Okay, so you tulis apa yang tinggal selebihnya. So write lah whatever left. Okay, so write, you put arrow first then write. Okay, whatever has before your arrow you have to place it first. So before your arrow yang you tak cut adalah your Mg and also 2 Ag plus, because you don't cut this thing what. So this is the remaining. So okay, put it first. Oops. Okay, and then after your arrow you have Mg2 plus and also 2 Ag. Okay, so tu satu. Sorry, there's not a technical error. Okay, so this one is your overall ionic equation. So dapatlah. Okay, so try to see betul tak? Yes, betul. Mg becomes Mg2 plus, meaning that the oxidation number increase, so it undergoes oxidation. Betul lah what you write at up there. 2 Ag plus yang ni jadi 0. So reduction happens. So betul lah you kata Ag plus, reduction occurs at the initially. So correct lah. Your what you call it, your working is correct as for now. Okay, then your sixth step. Okay, actually what I prefer my students is I ask them to write like this. Okay, I ask them to put the equation and then write overall ionic equation and then put the double dot. So it would be good enough for you. Okay, so overall ionic equation, this is your overall ionic equation, you will get the next mark. Okay, and then okay, after that only you will enter your cell notation part. Okay, so cell notation part, okay, I write at here number 6, which is cell notation. Okay, cell notation, we have a what you call it, we have a key. We would say A, B, C. Okay, what does your A, B, C stand for is your B is your bridge. Okay, so letak double dot. Okay, after that your A stand for your anode. So see your half equation for your anode. So your anode is Mg and Mg2 plus kan. So write it back. Dia mula dengan Mg, right? So you put Mg and then it finishes up with Mg2 plus. You just copy your half equation but no arrow. Electrons only to copy. Your anode start with Mg, so I write Mg first and then it finished with Mg2 plus, then only Mg2 plus. Okay, and then your cathode start with Ag plus. Okay, and then reduce to E ke atau Ag? Yes, Ag. E we won't write. Electron we won't write in cell notation. Cell notation don't like electron. So this is your answers. Okay, so I already adjust out. So this is your cell notation indeed. Okay, Mg, Mg2 plus. Okay, like this question, the equation I think don't have the concentration. If have, you must write lah. Okay, but mostly we won't care. So you write the aqueous ke concentration, we won't care. We just want you to write the element correctly. This one atom, this one ion, and atom balik. Because anode, you see, it start with Mg then Mg2 plus, and then cathode start with Ag plus and Ag. So settle lah. This is your cell notation. So I bring it up a bit. Okay, I hope you dah salin. And then your final step is your E naught of cell. Wait, I show you the formula. Okay, this is what that I'm telling you just now. Anode, bridge, cathode. Okay, So you can see here, okay, the formula voltage reading for E0 of the cell is this one. Okay, like what I tell you, E0 of the cell is equal to E0 of cathode minus E0 of anode. Why we use minus? Because the balance between both of the cells, I mean, wait, I'll show you the question again. Okay, the balance for, come on, okay, the balance, I mean, sorry, wait, where is the pencil? Okay, the balance for this one occurs when both of them has reached a stable value. Okay, they are a balancing, which is their potential difference. Okay, so for E0 for cell we want to find. Okay, E0 for cathode. What is your cathode? Your cathode is the more positive, so argentum is your cathode. Can you agree just now, right up there? So what is the value? Positive 0.80 volt. Remember, when you're doing the calculation with this formula, write the positive or negative value. Must write. Okay, tolak, just write tolak, and your anode they have negative, so negative 2.38. Jangan ingat this negative is same with this negative. No, it's different. This one is operasi tolak, while this one is the negative in the E0 itself. Okay, in the what you call that, in the value itself lah. So you press your calculator, positive 0.80 plus 2.38 volt. So overall I think you should get 3.18 watt. Betul ke? I tak ada calculator right now with me, so just calculate macam ni. 81, yeah, 3.18 watt. Okay, but make sure the value front there dia ada positive sign, baru betul. Okay, so you should put the positive. In chemistry I'm very particular with the positive and negative sign, so make sure if they are the positive, tulis the positive. If they are the negative, write the negative. Don't malas, jangan malas Okay, so settle lah your explanation for question number 3. So dia sometimes boleh bawa sampai 10 marks. Okay, so di manakah markanya? Markanya you determine magnesium electrode is your anode, because E0 value is more negative would be your first mark. With the process, you tell what happens. Silver electrode, this your cathode, because E0 value is more positive. Make sure you bagi the reason tau. Ingat for voltaic cell, the reason would be always E0 value. For voltaic cell, we won't consider other factors. We only refer E0 values in the standard electrode potential table. So you bagi tahu reduction occurs. So you got third mark, fourth mark. Half equation you buat correctly. You copy correctly from the table. Anode you reversekan because oxidation. Cathode you copy like that, you'll get 1 mark. And then your overall ionic equation correct, you dapat 1 mark. Cell notation correct macam ni. Anode, bridge, cathode. Anode dulu, bridge baru cathode, you got another 1. Ni formula and the final answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got your 10 marks here. So make sure you do like this, like what I did for you. So this is the complete answer scheme. Your first sentence you bagi tahu which one is your anode, which one is your cathode, with the reason and what process occurs there. The electrode, terminal apa, anode ke cathode, reason and what process. And then you do half equation. After half equation, always it should be your overall ionic equation. And then should be your cell notation and E0 for cell lah. E0 value for the whole cell. So I think one example is not enough for you, so I will do another one example. Maybe I will do question number 4 for you. Okay, or else in your textbook I haven't do yet that example, so I will use that example to teach. Maybe and anyone of it lah, up to me lah. Okay, so I hope you enjoy my lesson today, such a detailed lesson I guess. So meet you in next video. Bye bye.